In today's lesson, we are mastering the concept of inverse functions. This is a vital topic for your Cambridge IGCSE Additional Mathematics examinations. You will frequently be asked to determine if an inverse exists, find its algebraic expression, and understand the relationship between their domains and ranges. By the end of this session, you will be able to handle these exam questions with the precision required for an A-star grade. Today, we are exploring the concept of an inverse function. An inverse function, denoted as f inverse of x, is a function that reverses the operation of the original function f of x. If the function f maps an input x to an output y, then the inverse function f inverse maps that output y back to the original input x. Crucially, for a function to have an inverse, it must be a one-to-one function, also known as an injective function. This means that for every unique output value in the range, there is exactly one corresponding input value in the domain. Let's compare a many-to-one mapping with a one-to-one mapping. If a function is many-to-one, where multiple x values produce the same y value, it does not have an inverse over that domain. This is because the reverse mapping would be one-to-many, which violates the very definition of a function. To determine if an inverse exists graphically, we use the horizontal line test. Take the function f of x equals x squared. If we draw a horizontal line across the graph, notice how it intersects the curve at two distinct points. This tells us the function is many-to-one. For example, both 2 and -2 squared to give 4. Because the inverse would have to map 4 back to both 2 and -2, a unique inverse function cannot exist for this domain. However, we can make it invertible by restricting the domain. If we only consider x values greater than or equal to 0, the function becomes one-to-one. Now, any horizontal line hits the graph at most once, and the function is injective. Let's look at an exam-style conceptual question. Explain why the function g of x equals x squared plus 3 for all real values of x does not have an inverse. To answer this, we observe that g of x is a many-to-one function. For instance, g of 2 equals 7, and g of -2 equals 7. Since two different inputs produce the same output, a horizontal line y equals 7 intersects the graph twice. Therefore, it fails the horizontal line test, and no inverse exists. Always use the specific term many-to-one in your Cambridge exams to secure that explanation mark. A vital rule to remember for your exams is the swap of sets between a function and its inverse. The domain of f inverse is exactly the same as the range of the original function f. Similarly, the range of f inverse is the domain of the original function f. Visually, the graph of y equals f inverse of x is a reflection of the graph of y equals f of x in the line y equals x. Consider the exponential function f of x equals e to the power of x. It passes through 0, 1. Its inverse, the natural log of x, is reflected across the diagonal. Notice how the coordinates a comma b on the original function become b, a on the inverse. 0, 1 becomes 1, 0. This reflection confirms that the functions undo each other. To find the algebraic expression for an inverse function, we follow a standard 4-step process. This method is highly reliable for exam questions. Step 1. Replace f of x with y. Step 2. Interchange x and y. Step 3. Rearrange the equation to make y the subject. Step 4. Replace y with f inverse of x. The most challenging part is usually step 3, where you must use your algebraic skills to isolate y. Let's see this in action with a worked example. Example. Find the inverse of f of x equals the fraction 2 times -3 over x plus 1 for x not equal to -1. First, we write it as y equals 2 times -3 over x plus 1. Next, we swap x and y to get x equals 2y minus 3 over y plus 1. Now, we solve for y. Multiply both sides by y plus 1 to clear the fraction. X times the quantity y plus 1 equals 2y minus 3. Expand the bracket xy plus x equals 2iy minus 3. We need all terms with y on one side. Factor out y dot y times the quantity x minus 2 equals negative x minus 3. Divide by x minus 2. Y equals negative x minus 3 over x minus 2. To make this look cleaner, we can multiply the numerator and denominator by negative 1. Y equals x plus 3 over 2 minus x. Thus, the inverse function is f inverse of x equals x plus 3 over 2 minus x, for x not equal to 2. Let us apply these techniques to a Cambridge-style question. A function f is defined by f of x equals 3x minus 5, for the domain where x is greater than or equal to 0. Find an expression for f inverse of x and state its domain. First, let's find the expression. Step 1. Replace f of x with y. Step 2. Swap x and y. Now, we rearrange to make y the subject. Add 5 to both sides, then divide by 3. This is our inverse expression. Next, we must find the domain of f inverse. Recall the rule. The domain of the inverse is the range of the original function. Let's look at the original function f of x. Since it is a straight line with a positive gradient and the smallest x value is 0, its lowest value is f of 0, which equals negative 5. As x increases, the function increases. So the range of f of x is greater than or equal to negative 5. Therefore, the domain of f inverse is x is greater than or equal to negative 5. Always remember to state the domain using x, not f of x, to get the final mark. In your examinations, even the strongest students can lose marks to these simple errors. First, confusing f inverse of x with 1 over f of x. The negative 1 notation represents the inverse function, not a reciprocal. The function that reverses plus 2 is minus 2, not 1 over plus 2. Second, forgetting to interchange x and y. Some students try to rearrange the original equation y equals f of x to make x the subject, but forget to swap the letters at the end. Always swap them early to avoid using the wrong variable in your final answer. Third, incorrect domain for f inverse of x. A very common error is providing the domain of the original function as the domain of the inverse. Remember, swap them. The range of f becomes the domain of the inverse. Fourth, algebraic errors when x appears twice. As we saw in our fraction example, if y appears twice after the swap, you must factorize to isolate it. Many students get stuck here. Remember to collect all y terms on one side and factor out the common y. Finally, using the wrong notation in answers. If the question asks for the domain, your answer must be in terms of x. If it asks for range, it should be in terms of f of x or f inverse of x. To achieve top marks in your IGCSE Additional Mathematics exam, keep these professional tips in mind. Tip 1. Check your inverse with the composite property. You can verify your answer using the identity f of f inverse of x equals x. If you have time, substitute your inverse expression back into the original function. If they simplify to x, your answer is correct. Tip 2. Sketch the reflection. If a question asks for a sketch of the inverse, always draw the line y equals x first. Use it as a mirror to ensure your reflection is accurate. Ensure that intercepts swap. For example, if the function hits the y-axis at 4, the inverse must hit the x-axis at 4. Tip 3. Look for domain restrictions. When an exam question gives you a domain, like x is greater than some value k, it is often a hint that the function would not be one-to-one without that restriction. Use this to help determine the range. Tip 4. Use clear notation. Clearly label which line is the function and which is the inverse on your graphs. Examiners look for these labels to award marks for clarity and communication. Before moving to the next lesson, make sure you understand today's concepts and can solve the worked examples on your own. To continue your learning, check the links in the video description. Download today's notes and additional practice questions at www.exam-mate.com. You can also join our free Telegram channel for more revision resources, study tips, and updates. Thanks for watching, and see you in the next lesson.